Howdy folks, Mr. Reed here, and welcome to One More Question. So what we're going to be doing right now is a transformation, specifically a combination of transformations. So we're going to be involving stretches, reflections, and translations. And we're going to be taking a graph and an algebraic representation of a transformation. So g of x is equal to some transformation of an f of x function. And we're going to be drawing a new graph using all of this information. So if what you want to do is draw a graph for a combination of transformations, let's get to it. All right, so I already have kind of the generic transformational form written down, and the specific transformation that we are going to be using is written up above me. We have our graph as well. However, the transformational form that I have there is not exactly in the same form as the generic one I have written above the graph. So I'm going to write it just beneath so we can do a little comparison. And that is 2f onto negative x plus 2 minus 3. The difference between these two things is that I have something in front of my x, but it's not factored out in front of an x minus h bracket inside of my argument. I do want to do that, so I'm actually going to write below what it would look like if I were to factor that negative sign, or negative 1, out of the x and the plus 2 piece. So it would become positive x, but it would be minus 2 instead. That makes a big difference in the way that we're going to actually do the graph, because I won't interpret my h as being negative 2. It's going to end up being positive 2, which is really important. All right, so I would suggest for a question like this, I don't think I really used a lot of mapping notation when I was going through things myself, but I really like it now for exactly the type of graph that we have here. Some random piecewise function that really can be defined as linear pieces between nice points. And we're going to take these 4 nice points and find the new versions of these 4 nice points. We're going to do that by using a mapping notation. Mapping notation generally would take some xy point and map it onto 1 over bx plus h, comma ay plus k. For us, the 1 over b is going to be 1 over negative 1, which is just negative 1 again. So it's negative 1 times x plus the h value, which is an h value of 2. And then ay, my a is 2, y plus k, which is actually a minus 3. So this is going to give me my little recipe of, I'm going to cook all the points, and I want the f of x points to become new g of x points, and I'm going to do them one at a time. So I'm going to go left to right. My first point there is at negative 2, comma 3. And so that's going to map onto, I take the negative 2, it's negative, the x value, so it's positive 2 plus 2 is 4. And then I would have my y value is 2 times 3 is 6, minus 3 is 3. So I'm going to get a new point at 4, comma 3. I'm going to just put them all on after I do the mapping notations. So next up, I have, the next point is at negative 1, comma 2. And so following the mapping notation again, negative 1 in the x value. So it's negative 1, which is positive 1, plus 2 is 3. And for my y value, 2 times the y value, which is 2 times 2 is 4, minus 3 is 1. So we'll get a 1 there. Moving to my next point. My next point is at 1, comma 4. Okay. X value is going to be negative 1 plus 2 is 1. And then I have for my y value, 2 times 4 is 8, minus 3 is 5. All right, then we're going to move over to my last point, which is at 3, comma 4. And for that one, for the x value, negative 3 plus 2 is negative 1. And should be the same for the y value because it's a 4. I'm going to do it anyway, so it's 2 times 4 is 8, minus 3 is 5. But, I mean, it's the same y value at 4 to begin with, so it's got to be the same one afterwards. All right, so here are my 4 new points. So let's go ahead and plot them. So we get 4, comma 3, which is going to be right here. I'm going to get 3, comma 1, which is right here. I'm going to get 1, comma 5. Let's try that again. 1 comma 5, and then -1 comma 5. So I'm going to play connect the dots, but I'm going to do it kind of following the same sort of picture. So looks like this point down here, because of the reflection that's gone on horizontally, is going to be the equivalent of this point here. So it's going to go down to this, going to come back up to here, and then come across horizontally. So play connect the dots, got the new picture. It's been flipped horizontally, not stretched. It looks about the same width. That's good. It has a new height though. It used to be 2 units high and now it's 4 units high. That looks good too. And if I were to take one point and follow it along to make sure that it winds up in the right spot, I might take, for instance, like this point right here. I mean, that's what the mapping notation does. So that's probably a little overkill. I'm just going to say that this one is good. So that's what I would do if I were taking a graph and then mapping it onto a new graph by using an algebraic relationship that's already given. We make it to be in the same form as this transformational kind of generalized form. And then once we have that, we can identify our A, B, H, and K parameters. We can put that in a mapping notation, translate our points, and get the graph that we want. So if you found that helpful, like, subscribe, and as always, take care, folks.